Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I would like to present my final year project for semester 1 for the title An Analysis on Energy Consumption of Injection Molding Process Using BP Neural Network. So my name is Muhamad Afiq Hakimi bin Ahmad Siaman. My number metric is B091910007. So first of all, I would like to say thank you to my supervisor, TS Muhammad Faizal bin Halim, for his effort and his helping for me complete my final year project for this semester. And I would like to thank you for my panel. For the first, TS Dr. Shahibuddin Ikhwan bin Abdul Qudus. The second one, for the panel 2, TS Muhammad Hidayat bin Abi Rahman to watch my presentation video. So for the next, I would like to present the presentation outline for the first. So I have 7. The outline for the first one is introduction, problem statement, objective, scope research, literature review, methodology, and last but not least, the conclusion. So, for the first part, the introduction of the injection molding tools are frequently a complicated assembly of mechanical, electrical, pneumatic, and hydraulic components that must perform a variety of jobs. So, mold design must identify a device that will perform successfully in manufacturing regardless of its complexity. So, injection molding is the most widely used method for producing plastic components. Injection molding also may be used to create a wide range of items with varying size, complexity, and applications. So, this process necessitates the use of an injection molding machine, raw plastic material, and a mold. So in the injection molding machine, the plastic is dissolved and then injected into the mold where it cools and freezes. This is a highly designed method in the manufacturing business because it can make a complex shape plastic goods with high dimensional precision and quick cycle times. So, automobile industry, casings and housings of items such as computer monitors, mobile phones and other devices with a thin shell characteristic and typical examples for this introduction. And then, for the problem statement for my final year project, first of all, the energy usage during the injection molding process is the modest, according to some study that I found at the Google. Despite the fact that injection molding appears to be a low energy process at first glance, its vast scale makes its influence quite important, and even little efficiency improvements can result in huge energy savings. So in addition to having an impact on product manufacturing costs, energy consumption is a component of environmental effect and a crucial aspect of any overall sustainability strategy. So indeed, the majority of study into environmental effects of manufacturing processes and systems has been on energy consumption patterns, with energy reduction being a key aspect in sustainable manufacturing. So my objective for my final year project includes an analysis of the energy consumption of the injection molding process using the BP neural network, as well as an energy model that estimates energy consumption in the early stage. So we have 3 for the objective. For the first one, to minimize the amount of energy consumption by modifying the machining parameters. Then to make an analysis on injection molding process by using the backpropagation neural network method. Then to validate the final results. Then for the scope research, for the first one, we conduct a through investigation of the injection molding process and existing ways to modeling energy usage in this process. All experimental energy measurements, as well as processing settings, material, machine, and component parameters were obtained. Then, the models were run on the data from the experiments, and the results were compared to energy consumption measurements. Last but not least, backpropagation neural network was chosen as the ultimate solution for modeling energy consumption, as well as my title for this final year project. Alright, so the literature review part. I conclude I may have a 3 from the final year project thesis. So for the first one, the title is General Frameworks for Optimization of Plastic Injection Molding Process, the parameters, by the author Zuan Fongdang, were published on the 2014. So the method used is the direct optimization method. So direct optimization method is not often used in injection molding. This method requires a complex integration between simulation tool and optimization code. So there are several authors who have used this approach. They propose a genetic algorithm which is gradient hybrid approach for injection molding conditions optimization. So genetic algorithm method optimization approach requires a huge number of functions evaluation or an enormous number of simulation cycles. The parallel computing can reduce the simulation time when some computers run simultaneously. So their approach combine an optimization algorithm and commercial workflow software with a dominance-based constraint handling technique. This is also be carried out using only gradient-based optimization techniques. So sometimes this approach focuses quickly when the optimization problem is low nonlinear. And then for the second one, for the methodology, in general, using the BP neural network approach to improve product and process quality includes 4 steps below. So the quality of work improves when a high-level performance is consistently reached. For the first one, the brainstorming. We establish the project purpose and the factor levels and all the contributing variables. Then we designing the experiments. So we choose an appropriate orthogonal array. Then we assign a factor and an interaction to each column. So we can determine the sequence and number of trials to repeat. After that, we running the experiment using the BP neural network to run the test. So last but not least, we analyzing results to establish the best design, the impact of various element, and optimal performance. So for the flowchart, we will start the experiment that we create initial random population. Then we perform artificial neural network simulation by evaluate genetic algorithm fitness function. Other than that, we use the backpropagation neural network to fitness this simulation. So after that, we have two option that maybe we will repeat or we will continue the simulation. So is the optimization creation. So if no, then we will repeat. We go to the selection first of all, and then crossover, then mutation to repeat the test again. If we have achieved the optimization criterion, so we will have the final fitness a winner. Then we will get the output, the optimal result based on the purpose of this project. So for the next, my final project, machine setup and material selection. So in order to produce a reasonable final result from the injection molding process, the essential parameter settings must be done before the beginning the machine, because it is critical to set the proper parameter setting before analyzing the injection molding flow during simulation. These issues are likely to develop in the chosen component during simulation. So in this study, we will require the injection molding measures fixed parameter configuration. So the fixed parameter values are based on the injection molding equipment available at the Faculty of Manufacturing Engineering Technology at the University Technical Malaysia Melaka or UTM. The phase material for material selection is ABS plastic Toyolak from Torre Plastic Malaysia, which is accessible in the faculty. So for the first table that we can see in this slide video, injection molding parameter and their level. So we have 7 factor from A, B, C, D, E, and F. Then we use the mold temperature, melting temperature, baking pressure, baking time, cooling time, and injection speed as the parameter. And then for the second table, for the experimental plan using an L18 orthogonal array. This means we use orthogonal array as the method for this injection molding parameter level. So we will test 18 experiment, and also we use the same parameter just for the table just now. For the first one, mold temperature and then melting temperature, packing pressure, packing time, cooling time, and injection speed. So after that, there is a significant difference between trial and error by using the BP neural network technique. So the BP neural network technique to design of experiment may cheaply meet the demands of problem solving in product or process design optimization projects. The engineers and the researchers can considerably shorten the time necessary for experimental studies by understanding and utilizing this approach. So this method of design of experimental use of the BP neural network techniques aims to increase quality, which is defined as performance consistency. Where variety is eliminated, consistency is established, so this may be accomplished by bringing the average performance closer to the objective and lowering fluctuation around the target. So the BP neural network experimental design approach was created with the goal of reducing variance. As a result, so this method is focused on achieving the indeed quality target of at each phase. The traditional design of experimental does not address quality in any way. So last but not least for this part, for the conclusion, I will say that as a result of lower energy use, manufacturers' expenses are low, and their ultimate goal is to make a profit. So this case study illustrates how energy consumption may be low without compromising product quality by adjusting the measuring settings. As a consequence, the product will continue to sell at a low energy prices, which is it will have a beneficial impact on all elements of sustainability such as environmental, economic, and social. So in the following chapter, define this estimate model methodologies provided in this chapter will be proven, confirmed, and further validated. So thank you for watching my presentation. I will hope all of you will like it. So Assalamualaikum warahmatullahi wabarakatuh. So thank you.